Whoop. There it is. Doing our review. Finishing up our review. So this is the 5.5 material where we are looking at operations and composition.
This is literally just the last one.
All right. So when I'm dealing with our functions, I'm going to read the directions through. It says f of x equals this thing and g of x equals that thing. Identify the rule for the following functions. I probably shouldn't have written that there because when I look at a function, f of x, that tells me the name of the function. Yeah, I'm writing right. There we go. That is the name of the function. The negative x plus 6 is considered to be the rule. Right? Whenever we're dealing with functions, yes, it's easier to see it in terms of y equals something or y equals something else. But when we're dealing with more than one function, it's beneficial to have a name for that function to distinguish the difference between this y equals something and that y equals something. Right? So that's why we have names, or one of the many reasons why we have names. Right? So again, this is the name, and that 5x is the rule. So dealing with a problem like 48. 48 says f plus g. F plus g. Is that the name or is that the rule?
Name.
That's the name. Right? So I'm going to take the rule for f and add it with the rule for g. So we have negative x plus 6 is going to get added with 5x. All right, what do we do whenever we're dealing with addition of polynomials? That's it. Ignore our parentheses, CLT. We should end up with 4x plus 6. We're okay with that?
Legs.
Biscuits. All right. 49. Similar story. We have f minus g. Now, my hope is that everybody understands that subtraction order matters. Mm-hmm. Right? So dealing with f minus g, the f minus g, that's the name. And what it tells us to do is to take the rule for f and then subtract the rule for g. So the rule for f minus the rule for g. So what's going to go inside here? Negative x plus 6. And what goes here? 5x. Now, when we're dealing with polynomial subtraction, what's different for polynomial subtraction versus addition? We've got to distribute the negative. And here, distribution is multiplication. So we're multiplying this negative with a positive 5x. So negative x plus 6 minus 5x. And now, combining like terms, what do we end up with?
6x plus 6.
Perfect. Negative 6x plus 6.
That's totally what I meant to say. I don't think I said that.
You nailed it. 50. Now we're dealing with composition. What did I tell you is the way to think about function composition? What do I think about when I think about? Yeah, our Russian nesting dolls. Right, so Russian nesting doll, we're putting one inside of another. And in this instance, we're putting a function inside of a function. Oh, 50, excuse me. Well, similar notation. All right, so on 50, we're looking at g of f of 2. That's it.
I can totally see.
So that means that the outer function here is the g function. So if I were to start with g of x equals 5x and I asked you to find g of 3, what would we do?
3 and 4.
Replace the x with a 3, right? And then we'd multiply to get 15. But in this instance, I'm not replacing the x with a 3, I'm replacing the x with f of 2. So I would have 5 times, not a 5. 5 times whatever f of 2 is. Now, how would I figure out f of 2? F of 2 is negative x plus 6, but instead of an x, what are we going to put there?
Negative 2.
A positive 2.
Oh, yeah.
Yep.
It would be in
It will end up becoming negative, yeah. So negative 2 plus 6. Right, the f function is defined as negative x plus 6, and f of 2 would be defined as negative 2 plus 6. Right, so negative 2 plus 6 gets us
4.
And 5 times 4. Good. Problem 51, we're looking at f of g of negative 1. So our outer function here is the f function, so what we're looking at is negative x plus 6. What's going in for x this time? Yeah, that g of negative 1 is going in to replace x. Now, what is g of negative 1?
Negative 5?
Yeah, 5 times negative 1, absolutely. So we end up with negative 5 times negative 1 plus 6. And to simplify that, 5 times negative 1 is negative 5. The opposite of negative 5 is 5. And 5 plus 6 is 11. Alright, so 5 was all about operations and composition. Operations are exactly what you think they are. They're fairly simple. We're just following what the naming tells us with the rules. Composition is your Russian nesting dolls. I'm plugging something in for something else. Alright, 5-6. This is the last thing we have to do for this unit. So 5-6, this is all about inverses or inverse functions. Dan, what's the big word I want you to think about when we think about inverse functions? Right as you took a bite of breakfast. Congratulations. Remember? We wrote it in big bubble letters with colors. Switch is exactly right. So, what are we going to switch in the process of finding an inverse function? What are we going to have to switch?
Everything.
Yeah, when you say everything, what are the two main pieces of a function? We have inputs and outputs, right? So what gets switched around are your inputs and your outputs. So we'll have to switch around our x's and our y's. Alright, so here we go, problem number 54. It tells us to find an equation for the inverse function. It does not tell us that we have to restrict domains or do any of the other things. But this parabola on 54, if I were to restrict the domain, what would I restrict it to so that the inverse would also be a function? That would be the left side. 0 to infinity, right? Negative 4x squared plus 3. What are the transformations? Well, it got shifted down 3 units, reflected, so it's facing down, and then stretched by 4. So it's just a skinny parabola that's been shifted down 3 units facing down. The vertex is the coordinate point 0, 3. And if I want the right-hand side of that graph, the right-hand side, I would be using 0 to infinity. Does that make sense? Mm-hmm. Okay. So to restrict the domain, if I were to restrict the domain, I would restrict it from 0 to infinity. Alright, so let's go figure this guy out. I'm going to replace f of x with y. So y equals negative 4x squared plus 3. That's the original function. What do I have to switch to find the inverse? The x and the y. So instead of y equals, I have x equals. Instead of negative 4x squared, I get negative 4y squared plus 3. And now we have to solve for y. Cade, what's your first step? You got that right. So x minus 3 is equal to negative 4y squared. All right. Cade, what's going to be your next step? Nice, good job. Yep, divide both sides by negative 4. So once that cancels out, we're left with y squared on the right side, and we get x minus 3 over negative 4 on the left side. Yeah, now we got to root both sides. And normally, when we square root, we get positive and negatives, right? When we're solving an equation and we take a square root, we get positive and negatives. But the domain restriction allows me to ignore the negative side. Does that make sense? Is what I'm saying and how I'm saying it. Okay, good. So, this now gives me y equals the square root x minus 3 over negative 4. Now that I have y by itself, I have to replace it with inverse notation. That is f inverse of x equals the square root of x minus 3 over negative 4. We'll do one more. All right, let's go 55. 55. Got you. All right, so instead of f of x equals, real quick, that's a square root function. Does the shape of that graph require us to restrict the domain so that the inverse is also a function? No is the answer to that. I do not have to worry about domains with radicals, only with quadratics. All right, so dealing with this radical, we have a y equals the square root of x minus 4. Switching now my x and my y. What do I need to do next? Get rid of that radical. Square it. Square u. Square u. So x squared is equal to y minus 4. Last step, add 4 to both sides. So x squared plus 4 is now equal to y. So our inverse function is x squared plus 4. Would we end up getting the entire graph for x squared plus 4? Like, would the inverse of the original be an entire parabola? No. It would just be half of it, right? The original domain and range of this function are going, the domain of this function is the range of this function, and the range of the original is the domain of the inverse. So that range, for a radical shifted to the right 4 units, the range would just simply be 0 to infinity. So the domain of this function would be 0 to infinity. The question didn't ask us that part. The question isn't asking about domains and ranges, but I want to make sure that we talk about it. Okay? Questions about finding inverse functions. All right, sweet.